Okay, so with transition matrices, we're going to have an initial state. So it's generally what is, it's like the beginning scenario. So you might write that. So the beginning scenario, we find out what's happening. So say yesterday we had the transition between, there was two shops or car rental places, and I'm just making these up now. I can't remember what it was. Might be something like that. So they had this, and the percentage of cars changed from the ratio. So what you're going to start off is they'll say in the beginning, they'll say how many cars you had. So what you'll have is when you've got a 2x2 matrix, you're going to get a column matrix, a 2x1, and it'll say, like for say Bendigo and Colac, and it'll say initially what happened in the beginning. So say in the beginning I might have had 200 cars at Bendigo and 100 at the Colac's branch. So what they'll say is this is the initial state. So they give it SO, meaning state, and 0, like nothing's happened. So what you do is you can use the transition to find out what the next state is. So say I said this transition was a day-to-day transition. So it's showing me how the cars move around from different venues day to day. If I'm going to go find the state 1, so one day after, what I do is I do the transition times SO. So say, so you would do that. Now, if you want to, so this becomes S1, so you found day 1. If you want to find, obviously, day 2, or state 2 they call it, you'll do the transition times the one before. So you can always, you might write a little note, you can always get the next state matrix by multiplying the transition matrix. So they always use a T for the transition matrix. Multiplying the transition matrix with the state before. The one that happened before. So say if I went to find S3, if I need to find, I could do the transition state times S2, okay? So we can do it state by state, and this could take a while, because what if I said, if this was day to day and I said, I want to find day 30, that's going to take forever to get there. So what we can do is we can use this rule here to find any state as long as you've got the very first one. And so what this rule is saying, if you say you want to find state 3, what you're going to do is you would do, so if I'm trying to find state 3, you do the transition to the power of 3 times what originally began. Okay? So what a good trick to know is what you want to do, if this number is what you want, so you want state 3, this power and this number should add up to what you want. So see how 3 plus 0 equals 3. So say before here, up here, the power is 1. So I want state 3, but see how 1 and 2, 1 plus 2 does give 3, so you can do it. So the reason I tell you this is because sometimes you might not be given the original initial, but they might give you one. So say they gave you, they wanted to find state 20, and you had been given the transition and they told you what happened on state 5, what I'm going to do is I'm going to make sure that this number and this number add up to 20. So what would the power be that I need to raise that one to? Boys? I'd have to raise it to what? To get 20, I'd have to raise this to 15. All right, so we can find, to summarize this, they call, when you get the this method up here, the first method here, where you use the state before to find the next one, that's the recurrence rule. And we've seen that. Remember that, you know, if you see the word that symbolizing SN+1, it means how you get the next one. Yeah, the next one is found by using the transition times this SN, which is the next one, you use the one before. Yeah, we saw that in recurrence relations, so we're used to that. It's just a way to write that out. But this one is how we can do it quickly if we've given one. And I often call this one the power trick one. So you'll often hear me refer to the power trick one method. Okay, so let's go to an example. So here it says, the factory has a large number of machines, and the machines can move from two states. They're either operating or broken. Broken machines are repaired and come back into operation, and vice versa. So initially, when you see this word here, they're setting up your SO. So you can say, so initially 80 machines were operating and 20 were broken. So I've got the operating and broken, and then they've given you a transition matrix here. So this would be operating and broken, operating and broken. So just to refresh, like what we did yesterday, looking at that transition, I would have either you're operating or you're broken. Now, 85% of operating machines on one day, 85% of operating machines on one day are operating the next day. And broken to broken, that's 95% of the machines broken one day are still broken the next day. And then you have these other things. So you've got operating today, broken the next day, 15%, broken today, operating the next day is 5%. So that's what they would have told and what they found. So then they created that transition matrix. So it says here, determine the number of broken machines after 10 days. So what I'm going to use is the power trick method, where I said SN is transition N times SO. Okay, so what in this example, I want after 10 days. So this is saying I want state 10. So I'm going to do the transition to the power of 10 times SO. So into your calculator, you would type that transition matrix out. And so while you're writing, make sure, double check they're adding up to 1, so that you make sure you've entered it in. So this is what we're going to do. So we'll do it on the calc. Okay, so we found out that S10 was 30.9 and 69.1. Okay, so, and I just mentioned here that because initially we add up to 100 machines, we always should have 100 machines when we're finishing, because we're not losing any. So when I tidy this up, I'm going to round this to 31 and that leave this one as 69. And I double check that they do add up to 100, and that they do, and that makes sense. All right, so with this example, the survey shows that 75% of the time customers will continue to purchase their groceries from store A if they purchase their groceries from store A and then in the previous month. So just a few little things they're doing. You can see we've got store A, obviously, and it says 25% from store A back to store A. And they're saying that this statement is from month to month. So you might want to note down that this is going to be the states a month, talking about months, where the other one we were talking about maybe days. All right, and then they've got a little bit of information that if you purchased groceries from B from store A previous month. So where was, sorry, that was 25%, sorry. So anyway, they've set up this. So how many customers are still purchasing their groceries from A and B at the end of 2 months if 300 customers started at A and 300 at B? So here they gave you this initial state matrix. So we've got A and B, and they said initially there was 300 at each. So then you had to set up the transition matrix. Sorry, so 75 from A to A, there they've put that there, and then it was 0.25 to B, and then they told me 80% go from B to B, and therefore I could see that that one had to be 0.2 because they add up to 1. Okay, so it says what, so they want to know how many after 2 months. So I would want S2. So I'll do the transition to the power of 2 times SO, and I'll get my answer. So if I do that on the calc, so if we go back to here, this is what we get when we type it in our calculator. So we're talking about customers. So I'm going to round to 277. Oh, sorry. 267. No, 277, sorry. 277, and the last one, bottom one, I'm going to do 323, and they add up to 600, so that's okay. All right. What percentage of customers are purchasing their groceries at A and B at the end of 6 months if 50% of the customers started at A? So this is just, you can have a percentage initial state. So say here they said they're talking about the initial state. Instead of using the numbers, we can just say, all right, SO, we had 50% at A, and then the other 50% had to be at B. Okay, so they want to know at the end of 6 months, so that would be state 6. So I do the transition to the power of 6 times initially the percentages, okay, and then that will tell me here is going to tell me the percentages of A and B. So we'll go do that on our calc. Yeah, so good question, because this question was how many customers are still purchasing their groceries from A and B at the end of 2 months. So here we just say, on this first one, we'll just say A equals 277 customers and B equals 323 customers. You don't have to write a full statement, but you probably do need to write that out. So then when we did the percentages, it says what percentage in a whole number. So I'm going to change these to, this was 475 and this was 0.525. So see how both of these are both on 5? So technically we would round up, but because we want it to match to 100%, you have to like round one up and one down. So they would accept both options, but you do need to make sure that one is 100. So in the end, I'm going to say, if I just say A, so A equals, I'm going to keep that one at 47%, and B I'll say is 53%. Okay, so they would have accepted, because they're both on 5, they would have accepted A to equal 48 and B to equal 52 because you've got to round it somehow. All right, because technically it should add up to 100. So I'm not, this one probably wouldn't make it into an exam because there'd be too many people arguing. Because technically you should have just done both of them up, but it doesn't add to 100. So there's a little bit of a fault in that question. All right, so we actually did not, on our calculator, do the power. So this would be after 1 month if we did this one. Sorry. But it was a good thing to show you what it was when you have the both on the 5 for rounding. But if we go on to this next page, and they've actually done it correctly to the power of 6. So you can see down here, there's rounded nicely. Like you would round that up to 45 and the bottom one stays at 55. So after 6 months, it says write down the new. So this one they said write down the new initial state matrix. But if you had to make a statement, make sure that you write A equals 45% and B is 55%. So they do make a comment down here, giving only the entire matrix as the answer rather than answering the question that's required. You'll get no marks. So you've got to be really careful with what they're asking. So make sure you write out your answer, okay, correctly. Okay, moving on, interpreting transition matrices. So let us return, this is a yoga class. As we saw the following transition matrix. So I think it's whether you did a morning, lunchtime or evening yoga class. And here's the transition. So using the information alone, predictions can be made. So they said if 30 people attend the morning session in this week, the transition matrix predicts. So if you know that there's 30 people here in the morning, you can find out other pieces of information. So it says 60% or 18 people will attend the morning session again. So what you know is because 30 people are there, but 60% go back to morning, so they're doing 60% of 30 to get the 18. Or we can say that 10% or 3 people change to lunchtime, so they're doing this one here, so 10% of 30, they know that. And you can also work out, you know, how many people go to evening because of the 30% and so on. All right, so we can interpret a few things individually. So let's go do some questions. So a small shopping centre has 2 coffee shops, Fatima's and Giorgio's. The percentage of coffee buyers at each of the shop changes from day to day and is shown in the transition matrix. All right, so we've got a transition. So best that we're starting to write, or we can see that's transition. So on Monday, 40% of coffee buyers bought their coffees at Fatima's. So right here, they're helping you set up a state matrix. So this is setting up a state matrix. So a state matrix, and we can call it our beginning one if we want. So here I said if they're saying 40% is at Fatima's, well, it has to add up. There's 100% of customers. They're either going to either one of those two. So if 40% go to Fatima's, 60% are going to Giorgio's. Okay. So it said the percentage, and this was on Monday. So Monday I called SO. All right. And then it said the percentage of coffee buyers who are expected to buy their coffee at Giorgio's on a Friday of the same week is closest to. So I can see if that was state 1, if Monday's SO, Tuesday'd be state 1, Wednesday state 2, Thursday state 3, and Friday would be state 4. So if I was going to use, I can use this formula if I like. Yeah, and I want to get state 4. So I'll be doing the transition to the power of 4 times what the SO, what originally happened. So in this example, I would have that, I'm not going to write it out, but that transition matrix here to the power of 4 times my Monday scenario. So we'll go do that on the calc. All right, so we found out this, and remember that the top one is Fatima's and the bottom one is Giorgio's, and they wanted to know what's the percentage who are going to be at Giorgio's. So I'm going to say 32%, which would be B. Okay, families in a country town were asked about their annual holidays. And every year families choose between staying at home, traveling, or camping. And the transition matrix is given. The transition matrix that provides the information in the above diagram. So we're just going to practice this. So we've got 3 sort of states we can be at. So we'll go across. Now I'm looking down here, they're doing home, traveling and camping that way. So I'll do home, traveling, camping the same way. So remember I said the ones back to themselves are often the easiest one. So H back to H is 0.3. If I go to T back to T, so T back to T is 0.5. And if I do the C back to C, that one is 0.6. And let's just fill in the other ones. So I'll start at H. If I start at H and I go to go to T, it's 45%. So this is 0.45. So what I do at this stage is I'm adding them up in my head and I'm at 0.75. So I'm hoping from H to C is 25%, because otherwise I'm reading this wrong. But that's correct. So H to C is 0.25. Okay, so let's go do T. So from T to H is 30%. So adding those two up, I'm at 0.8. So I want to see from T going to C to be 0.2. So T going to C, and it is. So I'm happy with that. That's good. And just doing the last one now, I want to go from C to H, which is there, 40%. And because that is already adding up to 100, this must be 0, and there's no other line, so that makes sense. So which one is this in our multi-choice? I think it's B. Is it? Yep. Yep. Okay. 2 politicians, Rob and Anna, are the only candidates for a forthcoming election. At the beginning of the election campaign, people ask who they plan to vote for, and here they're given. All right. So during the election campaign, it is expected that people may change their candidate that they plan to vote for each week. So they're saying the state is weekly. Okay. Now, the question down here, the total number of people who are expected to change their candidate that they plan to change their vote for 1 week after the election campaign begins. So originally, this is where they're all voting. They just want to know who changes. So we just want the changing percentages. So this is where I've highlighted in the green here, 24% of Anna will change to Rob. So I'm doing 24% of Anna's numbers. So 24%, and that was 828. And then people who changed from Rob to Anna was 25%. So 25% of Rob's ones voted changed. So then I've got the 2 changing amounts and I add them together, and that's how I got that answer here of 251. Often seen in exam, the question the other way is what percentage didn't change. So you're looking at those ones going back to themselves, and you do it the same way, but look at that. That question's been asked a couple times, so this is obviously they've changed it around, so you can get either way. Okay, so with the transition matrix below, so the transition diagram below has been constructed from this transition matrix, and the labeling in the transition diagram is not complete. So the proportion for one of the transitions is labeled X, and you have to find what X is. So we've got to have a look at what we've got, and we have to try and take that transition matrix and put it down into this diagram. So if you look here, I've got 0.4 going out of something into somewhere else. And if I look up in that transition matrix, there's only one 0.4. So, and that is going from M to F. So there I know, now I know those two. So now I know that this one over here is M. What I'm looking for is going out of M and to something is 0.1. And can you see that's T? So I'm going to put that as T. And therefore the last letter that I don't have must be L. So the question is X, which is L to L. So L to L, L to L is up here. L to L is 0.6. So I'm going to say there's my answer. Okay, this last one. So Stella completed a multi-choice test that had 10 questions. For each question had 5 possible answers, A, B, C, D, and E. For question number 1, Stella chose E. Stella chose each of the 9 remaining answers in order following the transition matrix below. What did Stella choose for question number 6? So what I do for these ones, because you could set up a state matrix if you like. Say state 0 or question, even if you want to say question 1, whatever. You'd have a 1 on E, so down here, and we'd have zeros on the rest. But what I reckon is easier to do is just to follow the transition matrix. So this question, she's here. She's on E. She's starting on E. When she's on E, she picks C for the next question. So I'm going to write C. So now she's sitting on C. She's now here at C. So what does she pick for her next question when she's on C?
A.
Good, excellent. A, because there's a 1 there. All right, so we saw she picked the A. So now I'm on A. So now when you're on A, what do you pick for your next question? Is it D? Yeah. So we got D. So now we're on D. Sorry, we're at D. What do we pick for our next question? Is B. Okay, and I don't know, back to B now. We're on B. What do we pick? We're back to E. Okay, so what does she pick for her 6th question number 6? She picked E. All right, so I think that would be quicker than doing that.